Einstein said in his essay, Physics and Reality, the most incomprehensible thing about the world is that it is comprehensible. The statement tackles the idea of why can the human mind understand the universe? Physics allows us to do so. For instance, in this video, I'm going to talk about and explain firsthand how a sport like soccer is simply physics, allowing us to comprehend it in terms of foundational physics principles. In this video, we talk about how Newton's laws help us understand motion, and how, when a ball is in motion, how projectile motion works, how momentum works, and how impulse works, and how factors such as air resistance, thermal energy make our world not an ideal world. For this reason, soccer balls run out of energy. Wake up, Isaac!
Isaac Newton is a well-known physicist. He came up with the laws of motion. He was sitting underneath a tree and an apple fell on his head.
Right then, after observing moving objects, using mathematics to understand further moving objects, and building off previous scientific works, he came up with the motion laws we know today.
Newton's first law states an object at rest will stay at rest unless acted upon by an unbalanced force, like this. However, the world we live in isn't an ideal world. For this reason, the ball stopped moving. This is because there are forces that aren't negligible. There are forces such as thermal energy, friction, and air resistance, causing the ball to stop moving, which we will go into later into the video. Force equals mass times acceleration. This is Newton's second law. This shows the relationship between force and acceleration are proportional. So when the force increases, the acceleration on the soccer ball would increase if the force applied to the soccer ball increased. And because the mass of the ball is constant for the most part, this would have almost no effect. For this reason, if we increase the force applied to the ball, the acceleration would increase. Newton's third law tells us that for every action there is an equal or opposite reaction. So that means if I kick the ball would have the same force back at me. For instance, when I kick this ball, the ball is applying the same force back at me, which is a reaction force. Now that we understand how a ball goes into motion, let's understand what a ball does when in motion. When an object is in motion, it experiences various types of motion. However, the three we want to focus on today are projectile motion, momentum and impulse, and energy. Projectile motion is when an object is in the air and is mostly influenced by gravity. For instance, when the ball is chipped over the keeper, it is mainly being influenced by the force of gravity if we state the other forces such as air resistance and other forces are negligible. And as a result of this, the soccer ball experiences a parabola-like motion, where it has a positive horizontal velocity, while it also has a positive vertical velocity. And it will only have a positive vertical velocity until it gets to its maximum height point, wherein which it is at a velocity of zero for an instant. Once it's at this velocity of zero, it will be accelerating down by the force of gravity by 9.8 meters per second squared until it comes into contact with the ground, where it will stop moving. And it will continue moving in the positive direction until this horizontal velocity becomes zero. Objects experience momentum, which is mass, and motion. The typical mass of a regulation size 5 soccer ball is 0.41 to 0.45 kilograms. And the formula to determine the momentum of an object in motion is P equals mv. P is momentum, m is mass, and v is velocity. And If I was running next to a soccer ball at the same speed, I would have a greater momentum than the soccer ball. This is because my mass is greater than the soccer ball's. So this shows that a truck moving slower than a car that is moving faster will have a greater momentum if the truck's mass is significantly greater than the car's mass. Impulse is the change in momentum, and impulse is equal to force times time. So with a greater force and a greater time comes a greater change in momentum, which is a greater impulse. So for a keeper trying to block the ball and trying to decrease the amount of force applied to them when blocking the ball, they will increase the amount of time it takes to block the ball in order to decrease the force that the ball is applying to their hands. And if they had a shorter amount of time to block the ball, then they would increase the amount of force in order to have a good impulse to change the direction of the ball or block the ball. So essentially, impulse is simply just force times time, which keepers use to block or change the direction of the ball. In soccer, the ball experiences mainly two types of exchanges in energy between kinetic energy and gravitational potential energy. When the ball is moving, it's got kinetic energy, and when it's in the air, it's got gravitational potential energy. The formula for kinetic energy is 1/2 mv squared, which means the velocity is especially important because it's squared. So a double in velocity will result in a quadruple of the value of kinetic energy. While this can't be said for gravitational potential energy because the mass, the gravity, and the height are all proportional. So when a soccer ball is kicked into the air, it is having kinetic energy. But when it's at its peak, it's got the most gravitational potential. And at that point, the velocity is 0 because it's the turning point. And at that point, all the kinetic energy when it was going up is transferred to gravitational potential. But when it's coming down, all that energy of gravitational potential energy is being transferred and turned into kinetic energy. And because of the law of conservation of energy, this would continue endlessly. However, we don't live in an ideal world. This is because in our world there is sound, heat, friction, air resistance, etc. And these would prevent from this pattern continuing on forever. So energy is essentially, in soccer, simply just kinetic energy and gravitational potential that are continuously exchanging energy in order to follow the law of conservation of energy. Air resistance causes energy to be dissipated from the system. This is because the energy such as kinetic energy and potential gravitational will leave the system because of external forces such as air resistance. As a result, the ball would eventually come to a stop because the world we live in isn't ideal, causing there to be forces that aren't negligible in reality which impact the energy of the soccer ball. Additionally, air pressure can cause the ball to curve because the air pressure on one side of the ball is stronger than the other side, causing it to curve into the weaker pressure side. This is called the Magnus effect. For instance, here you can see that the air pressure from this side is greater than the air pressure on this side. For this reason, the ball will curve into the goal from this side to this side. For instance, when I kick the ball here, the ball will curve because the air pressure on this side is greater than the air pressure on this side.